Parallel Lines by Mr. Sindel. So let's get some vocab out of the way. Parallel lines. These are two lines that are the same distance apart and never touch. They also share the same slope. I have an asterisk on never touch because sometimes they are the same exact line, in which case they're touching at an infinite number of points, but usually that doesn't happen. And a transversal line. In the bottom right, you can see a picture of the transversal line. It's just a line that passes through the other two lines. Usually the other two lines are the parallel lines. So it's the one that's the oddball out, I guess. Supplementary angles. This is just a fancy way of saying they add to 180 degrees. So if you have a line and you're looking at only one half of that line in terms of the angles, all of those angles will add to 180 degrees, and that is seen in the bottom right-hand side. No matter how I move these lines, no matter how I move E, how I move F, or the other point, I will always add up to 180 degree on that side. The general formula here is that the measure of angle A plus the measure of angle B is going to always equal 180 degrees. And you can have as many of these as you want as long as they're on the same side. Alright, so let's try an easy problem. Find the value of x. Notice that there's only one straight line and it's CAB. So 2x plus 3x plus 3x, they should add up to 180 degrees. So let's set that up. If I add 3x plus 2x and set that equal to 180 degrees, solved by dividing by 8 after I simplify, I get my x is 12.5. Now let's try a harder problem. So I need to find not only x, but the measure of angle ABD. ABD is this bottom angle down here. So how do I do that? I notice that there is a straight line down here. Part of that is taken up by 90 degrees, and then 19x minus 3 and 6x minus 7. So I just need to add all three of these together and say that is equal to 180. So when I do that, I say 19x minus 3 plus 6x minus 7 plus 90. All three of these add up to 180 degrees. Solve for x, and I get x equals 4. But I'm not done. I need to find the measure of ABD. So I plug in 4 for x in the 6x minus 7, and I find that that angle is actually 17 degrees. And I make sure to include my units. All right, vertical angles. This is pretty easy. It's just a pair of opposite angles, and they're always made by intersecting lines. Make sure they are, in fact, lines. They're not coming off at a weird angle from this point. And the thing you need to know is that the vertical angles are always congruent. A and B are congruent. So A and B are congruent. This is the second part of the formula, but the measure of angle A is equal to the measure of angle B, very similar to what I was talking about before. When I put the M in front of it, the measure, that means it's actually a number and it can be equal to something else. So how do I apply this in a problem? Our easy problem. Find the measure of angle x. Well, since they're the same, x is 138. That's pretty easy. Let's try something a little bit harder. So now I have some algebra involved. I just need to set 6x plus 5 is equal to 41. I do that and I solve. 6x plus 5 is equal to 41. Solve and I get x is equal to 6. Corresponding angles. So this is just angles that occupy the same position. So if it's on the top right in terms of F, it's going to be on the top right in terms of point E. It moves over. So the formula for this is that they're equal, they are congruent. The measure of angle A is equal to the measure of angle B. Or you can say that angle A is congruent to angle B. So I decided to make my proof on corresponding angles. So on the right, it does a really good job of showing that if you just translate that angle and move it up or move it down, it will be the same exact angle. It's just translation. The reason for this is that translation preserves angles. So I decided to write out my proof. I made my diagram. My statement is what I was given. I have lines L and M are parallel. That is given to me. And from that, I just know that the measure of angle ABD is equal to the measure of angle DEF because I'm just translating, and translation preserves angles. So how do I do problems on this? Let's try this easy problem. Find the value of x. I know that this is just a corresponding angle, so I just set them equal. So 26x is equal to 130. Solve for x. X is 5. Pretty easy. Let's try a harder example. Find the measure of angle EFD. EFD, that is this angle right here. So I need to solve for x, and then after that, I will plug it back in for the 4x plus 15. I know that corresponding angles are the same, so I set them equal to each other. Set them equal to each other, solve for x. X is 10. From there, I plug in 10 to the 4x plus 15. When I substitute 10 for x, I find that my measure of that angle was 55 degrees. Again, don't forget your units. Alternate interior angles. So this is the Z shape, the inside of the Z, or maybe the outside if it's stretched. This is congruent. Alternate interior angles are always congruent. So this is the same exact formula as before. The measure of angle A is equal to the measure of angle B, or angle A is congruent to angle B. So how do we do a problem? So let's try an easy problem. Notice that this angle up here on the top right is 90 degrees. This angle is just 3x minus 11. They should be equal because it's kind of the inside of the Z. It's alternate interior. So set them equal and solve for x. X is 7 in this case. All right, a harder problem. Another alternate interior. It doesn't exactly look like a Z unless you can see the Z has been stretched out, but it is still alternate interior. This 11x minus 6 is still equal to 9x plus 6. So set them equal to each other and then solve. I solve, I find that x is equal to 6, and I'm not finding x, I need to find the measure of BEF. BEF is this top angle up here. So to do that, I need to plug into 9x plus 6. I do that, and I get 60 degrees, remembering my units. Same side interior angles. So this is just angles that are on the same side of a transversal. They're on the right-hand side in this case, and they're in between the parallel lines. So the formula has now changed. It's that A and B, when you add them up, they are 180 degrees. They are supplementary. Notice that whenever I drag around point A, all of these angles always add up to 180 degrees. The sum is 180 degrees. All right, let's try an easy problem. So find the value of x. Well, I know that 144 and x are angles that will be supplementary. That means they will add up to 180 degrees. So say that 144 plus x is 180. Solving just by subtracting 144, we find that x is 36 degrees, remembering my units. And now for the harder problem, more algebra. Now I know that these two same side interior angles are supplementary, so they still add to 180 degrees. So set up the problem like before, only it's a little bit harder. I have 8x plus 11, the top angle plus this bottom angle, 17x plus 19, is equal to 180 degrees. From there, solve for x, and I find x is equal to 6. Thank you for watching.